Hi there. This is a video over Intermediate Algebra, Unit 1, Section 1 Guided Notes. What we're going to be talking about today are solving equations using the properties of equality to do that. So if you want to go through your standards here and your objectives, it gives you a clearer picture. I'm not going to read that to save you some time in this video. So what I first want to talk about are the properties of equality. So I've got all these true statements here. I've got 4 true statements. I got that 5 equals 5 3 times, and then 10 equals 10. What I want to do is take a look at this, and we all can agree that 5 is equal to 5, all right? Now, if I add 1 to the left side of this equation, all right, what do I have to do to the right side to keep it balanced? And the answer to that question is that I want to add 1 to both sides, all right? So add 1 to both left and the right, and then I get that 6 is equal to 6, and that is a true statement, okay? So when I add a number to both sides of an equation, that's called the addition property of equality. Okay? All right, now moving on, let's take a look at the next one. Now, if I've got 5 equals 5 here, if I were to subtract 1 from the left side of my equation, all right, what would I have to do to keep it balanced over here? So, and the answer to that question is I would have to subtract 1 from both sides, all right, so to the right side as well. So 5 minus 1 gives me 4. 5 minus 1 also gives me 4, and that results in a true statement. All right, so that is called the subtraction property of equality, okay? Now let's look at the next one. I've got 5 equals 5 again. Now for this, what I want to do is I want to multiply one side of this equation by a number, okay, in this case 2. And if I do that to the left side, I also have to do this to the right side, all right? So to keep it balanced, right? So if I do 2 times 5, that's going to give me 10. And then 5 times 2 also gives me 10, and that results in a true statement. So what I've got here is I've got a true statement by multiplying, and that's the result of doing the multiplication property of equality. All right. Now, the last one, you guessed it, is the division property of equality. So if I divide one side by a number, let's say 2 here, and divide this side by 2, then what happens is I've got 10 divided by 2 gives me 5. 10 divided by 2 gives me 5, and that stays balanced, okay? And so this is the division property of equality. And the whole point as to why I'm doing this is that these are the reasons why we can move from one step to another in an equation, okay? So the thing that I want you to understand is that, your objectives is that you will be able to explain each step in solving a linear equation, all right? Follows from the equality in the previous step. So this is the explanation. That's what we're trying to do. So let's jump down to some one-step equations here. These are the different kinds of one-step equations that you have. And again, when I'm solving, I'm trying to figure out what value for x is going to make this equation true, okay? Now, if I'm trying to isolate x, I want to move this positive 1. So the first thing that I would do is I would do the opposite of what it's telling me. I'm going to subtract 1. Now, if I subtract 1 from the left side of my equation, if I draw my line here, I also have to do it to the right side of my equation, okay? Now, if I do the math here, 1 minus 1 cancels out to 0. Drop down your x, and then you get 4 minus 1, which is going to give us 3, and that's our answer, okay? And we can always check our solutions by plugging it back in. And I could take this value of 3, substitute it back into my original equation, and then write plus 1 equals 4. 3 plus 1 is 4, and 4 equals 4. That's true. Therefore, this is my solution. Okay, but that's what we're doing. Now, if I look at this next example here, x minus 7 is equal to 5. What I want to do is I want to move this negative 7 to the other side. Now, let's draw our line down the middle. And let's go ahead and do the opposite of subtracting 7, which in this case would be adding 7 to both sides. All right, the negative 7 plus 7 cancels out, drop down our x, and then we get 5 plus 7, which is 12. And that's our answer for that one. This next one, if I've got 4x equals 8, what I look at and what I see for this is I've got 4 times some number x gives us 8. So if I'm multiplying 4 by x, that means that I would want to divide both sides by 4 to move that 4 to the other side of that equation. Now, what I can do here is divide out my 4s. 4 divided by 4 is 1. Drop down my x, and then I've got 8 divided by 4, which gives us 2, and that's our answer here. Okay, last one for a one-step equation. I'm going to draw my wall of algebra, my line, to show my left side, my right side. Now here, I'm taking some number x and dividing by 3 to get 5. So if I want to move this 3 to the other side and isolate x, I want to do the opposite of divide by 3. In this case, I'm going to multiply by 3 on both sides, okay? And because I have a fraction here, 3 divided by 3, this divides out to 1. Drop down your x, and then 5 times 3 gives us 15. And that's our answer for this. Okay, so that's the idea for those one-step equations. All right, let's take a look at these various types of two-step equations. So on this, what I look at for this two-step equation is I've got multiple steps. Now, a one-step equation in the beginning on this example here was that it took one step to arrive at my solution of x equals a number. Here, for a two-step equation, what I want to do is I want to move the number that's not attached to my x first. All right, so I'm going to draw my wall here. And what I'm going to do is I'm going to move this 8 to the other side. All right, so I'm going to isolate my 2x. So let's do this. The opposite of subtracting 8 would be to add 8 to both sides. All right, and then negative 8 plus 8, that cancels out. I'm going to drop down my 2x, and that's going to be equal to 16 plus 8, which in this case is 24, all right? So from here, I can divide both sides of this equation by 2, all right? Because now I've got a one-step equation. 2 times some number x gives me 24. The opposite of multiplying by 2 is to divide by 2. That's what I want to do to both sides. And then 2 divided by 2, that divides out. And then I am left with x on the left side, and then 24 divided by 2 gives me 12 on this right side, and that's my answer, okay? Let's take a look at the next one. 3x plus 5 equals 26. Let's draw our wall. Now, this is a very similar problem to the one we just had, except for instead of, we're adding 5 here. So again, I'm going to move this 5 first, move the 3 second. So my first step would be to subtract this 5 because that's the opposite of adding 5, all right? The 5 minus 5 cancels out, drop down my 3x, and then I've got 26, well, that should be a minus 5, all right? So a minus 5 here, so 26 minus 5 gives me 21, and then now I've got a one-step equation. So the last thing I'm going to do, I'm multiplying by 3 to that x. I want to do the opposite, which is divide by 3 on both sides, here and here. So then the 3's divide out, drop this down, and then x is equal to then 7, 21 divided by 3, and that's our answer. All right, let's take a look over at the last one. Now, this last one has a fraction in it, and that's okay. But I'm going to follow the same step. I'm going to move this negative 4 first, all right? Let's draw our wall of algebra. Let's, because we're subtracting 4 and I'm moving that to the other side, I'm going to add 4 to both sides. So from here, what I want to do is now cross off negative 4 plus 4 cancels out. I'm going to drop down my n over 2, and then that's going to be equal to 7 plus 4, which gives me 11. Okay, now because I'm dividing by 2, the opposite of dividing by 2 is to multiply both sides of this equation by 2. All right, so the 2's divide out, and then n is equal to 11 times 2, which is 22, and that's our solution, okay? So those are two-step equations, all right? So we've done one-step equations, we've done two-step equations. I now want to talk about multi-step equations where we combine like terms. So on this first one, what I want to do is I want to look at this, draw my line, my wall of algebra, and what you notice is that I've got these different terms here. I've got three terms. All right, so I've got the 4x, I've got this negative x, and I've got a minus 7, and then I got this 20 here. All right, now over here, what I can do is I can actually combine my like terms. That's going to be my first step. Whenever I see I have terms with multiple variables or multiple variable terms, I want to combine them. And I'm going to do that by just combining the numbers out front. So I've got the 4x minus 1x. Combine the numbers out front and keep your variable. So 4 minus 1 gives us 3. And then keep your variable x. Drop everything else down. And now we have a two-step equation. All right, so from here, I want to move this negative 7 over to the other side. Because I'm subtracting 7, I want to add 7 to both sides. All right? And so from here, negative 7 plus 7 cancels out to 0. Drop down our 3x, and then that leaves us with 27. Now we have a one-step equation. And here, I can divide both sides by 3. All right, to move that 3 over, all right, that's the opposite of multiplying by 3. And then our last step, drop down our x, and then we've got 27 divided by 3, which ends up giving us 9, okay? And that's our answer for that, okay? That's how we solve that equation. Let's try another one. And these are sort of the same thing, okay? Let's draw our wall of algebra. We've got the 6x and the 2x are the variable terms that we can combine. Again, I'm going to take the numbers out front, the 6 and the 2, and put them together. Add those together to give us 8, and then put the x down, and then drop everything else down. All right? So in this case, now I've got a two-step equation. I'm going to move this 5 first, and I'm going to subtract 5 from both sides. All right? Next step, that's going to cancel out. Drop down our 8x. And then we've got 40. That's a 45. Sorry, I keep screwing this up. All right, so 45 minus 5. And that's going to give us 40. Okay. Now, 8 times x equals 40. Opposite of multiplying by 8 is dividing by 8. So that's what we've got here. Now the 8's divide out, drop down my x. 40 divided by 8 gives me 5, okay? Now, if you're struggling with solving these, and I'm going pretty fast, so make sure you pause and rewind if you need to. But the reality is you should be able to explain how I get from one step to the next, okay? So here to here, I combined like terms. All right. Here to here, I did the addition property of equality. And then here to here, here to here, I did the division property of equality. So that's the important thing, is that I want you to be able to explain what you're doing from one step to the next. Okay, on this last problem on this page, we have what's called the consecutive integer problems, all right? So on this one's a little tricky, all right? And these are standard problems that you'll see on the SAT or other standardized tests like that, and it says the sum of 3 consecutive integers is 132. What are the 3 integers? So what I want to do is think about it. So consecutive integers, if I think about that, that's like saying, and I'm just going to do this. I'm going to do like 30, 31, 32. All right. This is an example of 3 consecutive integers. All right. Now, I don't know what my integers are, but what I do know is that I'm going to call my first integer x. My second integer, all right, I know is going to be that number, x plus 1. My third integer is going to be my first integer and then add 2. All right. Now, if what I can do from here is I can set up this equation and I can say that the sum of all these, which in this case is going to be x plus 1 plus x plus 2, is equal to 132. And what I can now do is I can solve this. And I can combine my like terms. If I have x plus x plus x, those 3x terms, that's going to give me 3x. If I combine my like terms for the other values, in this case the 1 and the 2, then that's going to give me plus 3, and then that's equal to 132. Now I have a two-step equation that I can solve. So from here, I could subtract 3 from both sides, all right? And this is going to give me, I'm going to draw my wall of algebra here. I'm going to drop down my 3x. And then this is going to give me 132 minus 3, which gives me 129. Okay? Now my last step here is to divide everything by 3 using the division property of equality. And so the 3's divide out, drop down your x. And if I do 129 divided by 3, that's going to give me 43. Okay, now what I found out is that that is my first integer, okay? So this value here is x. So my first integer is 43, and then my next two consecutive integers are going to be 44 and 45. And that's how you set up and solve a problem similar to this. All right, on this next page, what I want to do is use linear equations to solve some real-world problems, okay? So the example that we're given is that 4 friends use an online code to get discounts on concert tickets. They spent $312 on 4 tickets. What was the price of 1 ticket without the discount? Okay, so what I want to do is sort of like use this picture and use this information to help us, okay? The first thing that I know is that we bought 4 tickets, okay? And we don't know the price of those tickets, but we do know that there was a $15 discount per ticket to give us a grand total of $312. Now, discount means that we subtract, okay? So the first thing that I want to know is, what is the price of 1 ticket without the discount? And that's what the question's asking us, and that helps us develop what does our variable represent. And in this case, I'm going to use x, and that's going to be the price of 1 ticket, all right? And that helps me. I developed this statement based on the question that's being asked, okay? So now, here's what I know. I bought 4 tickets, all right? If I take 4 tickets times the price of the ticket, that will give me the total, right? So I'm going to do 4 times x. However, what we realized is that we got a discount of $15 per ticket, all right? And that information is from this table here. So what I'm going to do is I'm going to subtract 4 times 15, all right? That's the total discount price, and we can then pay a total of $312. So the hardest part about these is setting up this problem here and having the wherewithal to know how to do that, all right? And that's tricky, all right? But that's the idea, okay? That's how I did that. So now let's go through the steps on how to solve that, okay? The first thing I want to do is do this multiplication here with 4 times 15, okay? Now this negative sign here is just going to carry down into our next step. So I'm going to have 4x minus, now 4 times 15 is 60, and then that's going to be equal to 312. And what we have is we have a 2-step equation. The first thing I want to do is move this 60 over, all right? So I'm going to draw my wall of algebra, all right? And the first thing I'm going to do is I'm going to add 60 to both sides, all right? So those are going to cancel out. I'm going to drop down my 4x, all right? And I'm using the addition property of equality here. And if I add 312 to 60, that's going to give me a total value of 372. Now, because I'm taking 4 times x, all right, the opposite of multiplication is division, so I'm going to divide both sides of this equation by 4, all right? Now, 4 divided by 4, that divides out to 1. And then x is equal to 372 divided by 4, which ends up giving us a total of $93. And what that means, that's the price of one ticket, all right? So from here, what we can say, we can say $93, to answer the question, or the price of one ticket is $93. It sort of depends on what, how you want to go about that, all right? But that's the idea, okay? All right, the next one. All right, so on this one, we've got this problem here where it says LaTanya will walk her bike from her house to the bike shop, which is 1.5 miles from her house, to get the bike fixed, all right? She expects to wait 30 minutes for the repair, and then she will ride her bike home. Can she be home in 1 hour? All right, this is a very tricky question. All right, but what it requires you to do is to kind of analyze the problem and figure out, is this a reasonable situation? Okay, so the first thing that we have to know is this equation: distance is equal to rate times time. Okay, and what we know is we know the distance, okay, from the home to the bike shop is 1.5 miles. And we know the rate at which she walks and the rate at which she bikes, okay? And that can tell us the time. So what we can do is we can set up a bunch of different equations here, all right? I want to know the time that it's going to take for LaTanya to walk, okay? And what I know is the distance is 1.5 miles. So let's do this. So for walk, I'm going to say that the distance is equal to, the distance is 1.5. I'm going to substitute 1.5 in for D, and then 3 miles per hour times T. All right, now if I solve that equation for t, I can divide both sides by 3. And what I know is that the time that it would take, 1.5 divided by 3 is 0.5 hours. Okay, so that's the time that it would take her to walk, all right, and that's 30 minutes. And then let's talk about biking. All right, the distance is still the same. It's 1.5 miles, but it's 10 miles per hour here, and I'm going to divide this by 10 and this by 10, okay? So from here, that's going to end up giving us 0.25, or no, not 0.25. That's going to give me 0.15 hours, okay? And that's equal to t, okay? So the question is, she walks her bike to the bike shop. That takes 0.5 hours. So 0.5 hours. And then she expects to wait 30 minutes for the repair. Well, 30 minutes is equivalent to 0.5 hours. So 30 minutes equals 0.5 hours. So if I take 0.5 and then plus another 0.5 plus another 0.15, is that going to be less than 1 hour? Okay, and these are hours. So now if I take 0.5 plus 0.5, that's 1 plus 0.15. Is that less than 1 hour? And we get 1.15. Is that less than 1? So the answer to that question is no. All right, this is false. that it would take 1.15 hours for the trip, all right, to occur. So no, that's how we would look and analyze that. That's a little tricky, and that's a little bit more about analyzing, figuring out the time for each of these things to occur, all right, and then knowing to add them up and analyze that versus 1 hour, okay? All right, let's take a look at the last one, all right? In this one, Keenan will run 2.5 miles from his house to Jared's house. He plans to hang out for 45 minutes before walking home. How long will he be gone from home? Okay, so let's draw a quick picture here. All right, we've got Keenan's house, denoted by point K, and then Jared's house by point J. Now the distance between the two is 2.5 miles. Okay, now going to the house, plans on running. Okay, so running, all right, means that that's happening at 6 miles per hour. Now, the rate that it takes to go home by walking back home would be 4 miles per hour. Okay, so again, I'm going to use the distance is equal to rate times time formula. And so on this, just to reiterate, all right, Keenan will run 2.5 miles from his house, hang out for 45 minutes before walking home. How long will he be gone from home? So what I want to do is I want to add 3 things. The time to Jared's house plus time at Jared's plus the time going home. Okay? So the first thing that I want to do is figure out the time for each. Now, the time at Jared's, I know that that's going to be 45 minutes. Now, 45 minutes is equivalent to 0.75 hours, okay? So 0.75, because this is going to be in terms of hours, because we're given something in miles per hour. So time to Jared's house. Now I'm going to use my distance equals rate times time. So my distance is 2.5 miles. Traveling at 6 miles an hour times time. I'm going to divide both sides here by 6 and solve this equation for t. So t is then equal to 2.5 divided by 6, which gives us 0.416 hours. Okay? Now walking, so this is going to be 0.416. Now walking home is similar. I'm going to do, what do we got? We got 2.5. I'm going to do the same thing. So 2.5 is equal to the rate of 4 times t. Divide by 4, divide by 4. So I'm going to do 2.5, divide that by 4, and that's going to give me a time of 0.625 hours. Okay. Now, here's what I've got, 0.625. Now, in my calculator, what I want to do is, this answer over here was rounded, okay? And I want to use an exact value. So I'm going to do 2.5 divided by 6, and that ends up giving me like 0.41666 and all that. All right. I'm going to add that to 0.75 plus 0.625, and that ends up giving me a value of a total time. So total time. So total time would be 1.79 hours, okay? And that's the idea, all right? So, this is a little bit, piece by piece and figuring things out and how to, answer the question appropriately, but that's the idea of how we would go through that. So, hope you enjoyed this video. Please let me know if you have any questions, and we'll talk to you soon. Thanks a lot. Bye.